suppose this is velocity time graph. So here the slope is constant, which means that acceleration is also constant. Here since the graph is not a straight line, it means that the acceleration is varying with time. Similarly, we can have acceleration time graph also. This is a graph plotted between acceleration of particle against time, and the area below the acceleration time graph gives change in velocity. Now let's see the vector form of equations of motion. So first we'll see the equation v is equal to u plus at. So this can be think of as, suppose this is a vector u and this is a vector at. So this will be our vector v, which is equal to u plus at. Similarly, displacement is equal to ut plus half at square. So again we can think of it as, suppose this is ut. Here u is vector and t is scalar, so this is the case of a scalar being multiplied to a vector quantity, and this is half at square. So this will be our displacement vector, that is s, which is equal to ut plus half at square. Similarly, we had equation v square is equal to u square plus 2as. We can think of it as dot product of v into v, which will be equal to u dot u plus 2 into a dot s. So here all the three terms are scalar. So in this way we can visualize the equation that we have derived earlier in their vector form. Now let's see the equation of motion when initial velocity is 0. So here the value of u is 0, which means that particle is at rest initially. So if in the equation v is equal to u plus at, we put the value of u as 0, we'll get v is equal to at. Similarly, in the equation s is equal to ut plus half at square, if we put u is equal to 0, we'll get s is equal to half at square. And in the equation v square is equal to u square plus 2as, if we put u is equal to 0, we'll get v square is equal to 2as. So these are the equation. These three are the equation. So now we'll start the chapter projectile motion. So what is a projectile motion? Projectile motion refers to the motion of an object projected into the air at some angle. The important thing here is velocity of projection, that is the velocity with which the object is projected into the air, and the angle of projection, that is the angle which the velocity vectors make with the horizontal. So let's say this with the help of an animation. So here, as you can see, this is our projectile, which was thrown into the air with velocity u. So this is our velocity of projection. And the angle of projection is theta. So this is the angle which velocity vectors makes with the horizontal. So here we can see that we can resolve this velocity vector into two components, one along the horizontal, which will denote by ux. So ux will be equal to u cos theta, and ui will be equal to u sin theta. Now let's try to find out the equation of the path of projectile. So as we have seen, the velocity of projectile can be resolved in two components along horizontal and vertical direction. So the component of velocity in the horizontal direction is ux, which is equal to u cos theta, and in the vertical direction it's uy, which is equal to u sin theta. Now let's see what acceleration is acting upon this projectile. So there is only one acceleration, which is gravitational acceleration, that is g, which is acting upon the projectile, and it is in the negative y direction. So the acceleration in the x direction is 0, and the acceleration along vertical direction is minus g. So in time t, projectile will travel a distance x along the horizontal direction, and which will be given by ut cos theta, where t is equal to time. Similarly, in the vertical direction, the distance traveled in time t will be given by u is equal to ut sin theta minus half gt square. So these are the two equations, equation 1 and equation 2. Now from equation 1 we can write t is equal to x by u cos theta, and we can put this value of t in equation 2, so we can write y is equal to u sin theta into t minus half gt square. We can put the value of t as u cos x by u cos theta, so y will be equal to u sin theta into x by u cos theta minus half g x by u cos theta whole square. So finally we get the following equation: y is equal to x tan theta minus